Welcome, my dear learners, for this course on engineering graphics. In this module 2, we were discussing on orthographic projection of plane surfaces. So far, we have solved 22 problems on orthographic projection of plane surfaces. Moving ahead, the problem number 23 of our discussion states that a hexagonal lamina of sides 25 mm rests on one of its corner on HP, and the diagonal passing through the corner on which it rests appears to be inclined at 30 degrees to VP. The lamina makes 45 degrees to HP. Draw its projections. Since the lamina is resting on one of its corners on HP, the second position should show inclination with respect to HP itself, that is, the lamina makes 45 degrees to HP. And in the final position, I should show inclination with respect to vertical plane. What he says is that the diagonal passing through the corner on which it rests appears to be inclined at 30 degrees to VP. So it's clearly stating it is appears to be inclined. This is because once I incline the lamina at an angle of 45 degrees to HP, the diagonal length will be reduced. So since the length of the diagonal is changing from its initial position to the next position, I should go for apparent inclination, that is beta angle. So since he is clearly stating that it appears to be inclined, the 30 degrees what he has given itself is a beta angle for us. Come, let us solve this problem. The lamina is resting on one of its corner. So therefore, in the first position, I should take corner towards my left hand side. For hexagon, we know that we will get corner on either side. So first let me draw XY line. Drawn. Let us call this as X. This is VP. This is HP for first angle projection. So I want corner towards my left hand side. So to get hexagon with corner, take horizontal line of length equal to side length, which is 25 mm. So draw a horizontal line at a length of 25 mm. Now take this as radius and construct a circle. Now take this as radius and construct a circle. So constructing a circle by taking it as a radius and cut arcs at equal intervals. Cut arcs at equal intervals. Now join these arcs to complete the first position top view such a way that we will get corner towards either side. So join these arcs. So join these corners. So this completes the required hexagon. Mark A, B, C, D, E and F. Each side length measures 25 mm given in the question. So edge length is 25. Now take vertical projection and complete the front view. So take vertical projection. Take vertical projection. So this completes the front view. This is A dash, B dash, F dash. We have C dash, E dash and D dash. Now the second position should show inclination with respect to HP itself. He says that lamina is inclined at an angle of 45 degrees to HP. So draw 45 degrees. Draw 45 degrees. Let me draw a bit closer. Draw 45 degrees. We know the length of the lamina is equal to the diameter, which is 50 mm. So transfer the lamina, whose length is 50 mm. Transferred, mark the corners A dash, B dash, F dash, C dash E dash, and we have D dash. Now take vertical and horizontal projection and complete the sketch. Obtain the second position top view. So I'll take vertical and horizontal projections. So take vertical and horizontal projections. So taking horizontal projection, we have done. I have taken vertical and horizontal projections. Thereby I got the corners A, B, C, D, E, F. Now join these corners. You have A to B, B to C, C to D, D to E, and finally E to F. This angle is specified as 45 degrees. Now he says that the diagonal passing through the corner on which it is resting on corner A dash. The diagonal passing through the resting corner is AD. AD should be inclined at an angle of 30 degrees to VP. He clearly states that it appears to be inclined because original diagonal length is 50 mm, whereas now the diagonal length has been reduced. So therefore I should go for beta angle, since he is clearly stating it appears to be inclined. Given angle itself is beta angle for us. So directly you take 30 degrees. You take 30 degrees, since if I take at 30 degrees, okay, let us take at 30 degrees and incline. So there is a chance that FE might enter vertical plane. So for a safer side, let me offset it. So let me offset the XY reference line. So offset the XY reference line, and these two are parallel. So for which I will measure 30 degrees. So measure 30 degrees. Measured. So draw a line at an angle of 30 degrees. Drawn. So this angle is given for us, which is 30 degrees. On this 30 degree, the diagonal passing to the corner should come and lie. I will take it and place it like that. So therefore I will call this as A. Measure AD and draw AD. So I drawn AD. So I got D. Now we have AD with us. I want FB and CE which are perpendicular to AD. So therefore measure these lengths and mark them. Measure these lengths and mark them. So mark them. I mark them. So measure their length and transfer them. So draw the perpendiculars now. Transferred. So first I had drawn AD, marked these two lengths from A to here, D to here. Now we know that these two are perpendiculars. For FB and EC, AD is a perpendicular bisector. You get half above, half below, which are perpendicular. So transferred them. So I got B, C, E and F. Now joining which, I will get this final position top view, that is A to B, B to C, C to D, and then D to E, E to F. So the diagonal passing through the corner is inclined, appears to be inclined at 30 degrees. Now take vertical and horizontal projection and complete the sketch. If I take vertical and horizontal projection, first I am getting B. So B, then A, then C, then I have C, then I'll get F, then D, then D, and finally E. So B and F. So we have B and F, C and E, we have C and E, and we have D. So connecting which we have A to B, B to C, A to B, B to C, C to D, C to D, D to E, E to F, and then F to A. So we got A dash, B dash, C dash, D dash, E dash, and F dash. So this is the required solution for problem number 23. Now if I observe problem number 24, which states that a hexagonal lamina of size 25 mm rests on one of its corners on HP, and the diagonal passing to the corner on which it rests is inclined at 30 degrees to VP. The lamina makes 45 degrees to HP. Draw its projection. The problem number 24 is similar to problem number 25. The only difference is that here we have the corner, the diagonal passing to the resting corner appears to be inclined at 30 degrees to VP. Here we don't have that sentence appears to be inclined or appears in the top view is missing, which means that 30 degrees is a true inclination in case of problem number 24. So therefore I should go for beta angle for problem number 24. So first position and second position remains the same for problem number 24. In the final position, it is a true inclination given for us 30 degrees. So therefore I should go for beta angle. Retaining the first and second position, I will calculate the beta angle for problem number 24. So here, so this solution is diagonal passing to the resting corner appears to be inclined at 30 degrees. So this solution is for diagonal passing through the resting corner, appears to be, this is the word, appears to be inclined at 30 degrees to BP. So underline the word appears to be. So now I will give you the solution where he has given the true inclination 30 degrees. That is problem number 24. The first two positions remain same for both 23 and 24. So this is the final position for problem number 23. Whereas for problem number 24, 30 degrees is a true inclination. So therefore let me offset as usual. I'll offset as usual. So draw 30 degree line. Draw 30 degree line. Drawn. Now on this line you place the true diagonal. On this line you should place the true diagonal. So this is 30 degrees. On this line I should place the true diagonal. True diagonal is the diameter of the circle, which is 50 millimeters. So place 50 millimeters on this. So I marked 50 mm. Mark the true diagonal 50 mm and call this as corner A. I marked the true diagonal AD, which is 50 mm, to an angle of 30 degrees. Now fix the locus of D. Now fix the locus of D. I'll fix the locus of D. So this is locus of D. I fix the locus of D. Now intersect this locus by using apparent diagonal length. We know apparent diagonal length. Intersect this locus. Intersected this locus. Now join. So this is what required D for us. This is what the required D for us. Now join AD. Now join AD. Correct. So join AD. Joined. Now extend AD back to measure the beta angle. Extend AD back to measure the beta angle. Extended AD back to measure the beta angle. So now if I measure beta, I am getting the beta angle as 44 degrees. I am getting beta angle as 44 degrees. So I will mark beta here. Both are correct. You can either mark beta here. So since there is no space, I will mark beta here. Beta is found to be 45 degrees. Beta is found to be 45 degrees. So first I have drawn true inclination 30 and lay down true diagonal, which is 50 mm. Then fix the locus of D. That locus has been intersected by using apparent diagonal. So I joined AD and extended back to measure the beta angle. Beta angle is found to be 45 degrees to me. Now I have AD. So repeat the same procedure, that is measure these two lengths on AD. So measure those two lengths on AD, which is already known for us. Measured those two lengths on AD. Done. And transfer FB and EC, which are perpendicular to AD. So now transfer these two. Now transfer FB and EC. FB and EC. Transfer FB and EC. Transferred FB and EC. Now connect these corners to complete the sketch. So A to B, B to C, C to D, D to E, E to F, and F to A. So we have A, B, C, D, E and F. Now take the projection. So this is till B. Take the projection till B. Then I will get C. Then I will get C. C. Then I will get A. Then I will get D. Then I got D. Then F. And finally E. Finally E. So take horizontal projection. This is till D. Draw. This is till E. Extend it back till E. And here we have B and F. Here we have B and F. So now joining, which we have A to B, B to C, C to D, D to E, E to F, E to F, and finally F to A. that is A dash, B dash, C dash, D dash, E dash and F dash. So here we have y, xy like reference. So this is a solution for problem number both 23 and 24 in a single sketch I have given. So these two positions remain same for both the problems, whereas for problem number 23 he himself has been specified 30 degree as beta, whereas for problem number 24 we should calculate the beta. Beta is found to be 45 degrees. So this is solution for problem number 24, wherein which diagonal passing through the resting corner is directly inclined at 30 degrees to VP. So this gives us the clear indication between beta and non-beta problem for you. Hence I have given solution for 23 and 24 together. So this completes the solution for problem number 23 and 24. That's all from this lecture. Thank you all.